Hi, I'm Rijesh, and today we'll be discussing a new chapter from the physics section, that is electricity. In this chapter, we will discuss electric potential, electric current, electric power, and the heating effect of electric current. In order to understand electricity, we should first know something about the electric charges. So, these are discussed below. If you bring a plastic comb near some very tiny pieces of paper, it will not have any effect on them. If, however, the comb is first rubbed with dry hair and then brought near the tiny pieces of paper, we find that the comb now attracts the pieces of paper towards itself. This observation are explained by saying that initially the comb is electrically neutral, so it has no effect on the tiny pieces of paper. When the comb is rubbed with dry hair, then it gets electric charge. The electrically charged comb exerts an electrical force on the tiny pieces of paper and attracts them. Similarly, a glass rod rubbed with silk cloth and an ebonite rod rubbed with woolen cloth also acquire the ability to attract small pieces of paper and are said to have electric charge. By convention, the charge acquired by a glass rod rubbed with silk cloth is called positive charge, and the charge acquired by an ebonite rod that is rubbed with woolen cloth is called negative charge. The important property of electric charge are opposite charges attract each other and similar charges, that is like charges, repel each other. The SI unit of electric charge is coulomb, which is denoted by the letter C. So 1 coulomb is that quantity of electric charge which exerts a force of 9 into 10 raised to power 9 Newton on an equal charge placed at a distance of 1 meter from it. A proton possesses a positive charge of 1.6 into 10 raised to power minus 19 coulomb, whereas an electron possesses a negative charge of 1.6 into 10 raised to power minus 19 coulomb. It is obvious that the unit of electric charge, called coulomb, is much bigger than the charge of a proton or an electron. Thus, the SI unit of electric charge, that is coulomb, is equivalent to the charge contained in 6.25 into 10 raised to power 19 electrons. Thus, coulomb is a very big unit of electric charge. Now, let us discuss what we can understand by the terms conductors and insulators. In some substances, the electric charges can flow easily, while in others, they cannot. So all these substances can be divided mainly into two electrical categories, that is conductors and insulators. Those substances through which electric charges can flow are called conductors, but the flow of electric charges is called electricity. So we can also say that those substances through which electricity can flow are called conductors. All the metals like silver, copper, aluminium are conductors. The metal alloys such as nichrome, manganese, and constantan, that is, they are actually used for making heating elements of electric appliances. So all these three are also conductors, but their electrical conductivity is much less than that of pure metal. Carbon in the form of graphite is also a conductor. Our human body is a fairly good conductor. Those substances through which electric charges cannot flow are called insulators. In other words, those substances through which electricity cannot flow are called insulators. Glass, ebonite, rubber, most plastics, paper, dry wood, cotton, mica, bakelite, porcelain, and dry air are all insulators because they do not allow electric charges or electricity, we can say, to flow through them. In the case of charge insulators like glass, ebonite, etc., the electric charges remain bound to them and they do not move away. All the conductors like metals have some electrons which are loosely held by the nuclei of their atoms. These electrons are called free electrons and can move from one atom to another atom throughout the conductor. The presence of free electrons in a substance makes it a conductor of electricity. The electrons present in insulators are strongly held by the nuclei of their atoms. Since there are no free electrons in an insulator which can move from one atom to another, an insulator does not allow electric charges to flow through it. Electricity can be classified into two parts: static electricity and current electricity. In static electricity, the electric charges remain at rest, they do not move. The charge acquired by a glass rod rubbed with a silk cloth and the charge acquired by an ebonite rod rubbed with a woolen cloth are the examples of static electricity. The lightning which we see in the sky during the rainy season also involves static electricity. In current electricity, the electric charges are in motion and produce an electric current. The electricity which we use in our homes is the current electricity. In this chapter, we will discuss only current electricity in detail. So, when we talk of electricity in these discussions, it will actually mean current electricity. Let us discuss what is electric potential. The electric potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point. Potential is denoted by the symbol V and its unit is volt. A potential of 1 volt at a point means that 1 joule of work is done in moving 1 unit positive charge from infinity to that point. Now, what is potential difference? The difference in electric potential between 2 points is known as potential difference. The potential difference between 2 points in an electric field or electric circuit is defined as the amount of work done in moving a unit charge from one point to the other point. That is, potential difference is work done per unit quantity of charge moved. Therefore, we say that V equal to W by Q, where W is work done and Q is the quantity of charge moved. The SI unit of potential difference is volt, which is denoted by letter V. The potential difference is also sometimes written in the symbols as PD. The potential difference between 2 points is said to be 1 volt of 1 joule. The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to another. Thus, 1 volt is 1 joule per 1 coulomb. The potential difference is measured by the instrument named as voltmeter. The voltmeter is always connected in parallel. The another name for voltage is potential difference. Let us understand what is electric current. When two charged bodies at different electric potentials are connected by a metal wire, then the electric charges will flow from the body at higher potential to the one at lower potential till they acquire the same potential. This flow of charges in the metal wire constitutes an electric current. So, it is the potential difference between the ends of the wire which makes the electric charges or current to flow in the wire. The electric current is a flow of electric charges, that is, they are called as electrons in a conductor such as metal wires. The magnitude of electric current in a conductor is the amount of electric charge passing through a given point of the conductor in 1 second. Hence, we say that I equal to Q by T, where if the charge of Q coulombs flow through a conductor in time T seconds, then magnitude I of electric current flowing through it is actually I equal to Q by T. The SI unit of electric current is ampere, which is denoted by the letter A. When 1 coulomb of charge flows through any cross section of a conductor in 1 second, the electric current flowing through it is said to be 1 ampere. That is 1 ampere equal to 1 coulomb per second. That is 1A is 1C upon 1S. That's 1 second. So just go through the conversions, like 1 ampere is 1000 milliampere, 1 ampere is 1000 into 1000 microampere. Okay, so current is measured by an instrument called ammeter. The ammeter is always connected in series. Since the entire current passes through an ammeter, therefore an ammeter should have very low resistance so that it may not change the value of current flowing in the circuit. Now, how to get a continuous flow of electric current? So we have just studied that it is due to the potential difference between 2 points that an electric current flows between them. The simplest way to maintain a potential difference between the two ends of the conductor so as to get a continuous flow of electric current is to connect the conductor between the terminals of a cell or a battery. Due to the chemical reactions going on inside the cell or battery, a potential difference is maintained between its terminals, and the potential difference drives the current in a circuit in which the cell or battery is connected. Direction of electric current. The conventional direction of electric current is from positive terminal of a cell or a battery to the negative terminal through the outer circuit. Let us understand how the current flows in a wire. We know that electric current is a flow of electrons in a metal wire when a cell or battery is supplied across its ends. A metal wire has plenty of free electrons in it. So when the metal wire has not been connected to a source of electricity like cell or battery, then the electrons present in it move at random in all directions between the atoms of the metal's wire as shown in the figure. When a source of electricity like a cell or battery is connected between the ends of metal wire, then an electric force acts on the electrons present in the wire. Since the electrons are negatively charged, they start moving from negative ends to the positive ends of the wire. This flow of electrons constitutes the electric current in the wire. Electric circuits and circuit diagrams. A continuous conducting path consisting of wires and other resistances like electric bulb, etc., and a switch between the two terminals of cell or a battery along which an electric current flows is called a circuit. The battery is a combination of two or more cells connected in series. The resistance, which can be changed as desired, is called variable resistance. Variable resistance is also known as rheostat. Rheostat is used to change the current in a circuit without changing the voltage source like the cell or battery. It can do so by changing the resistance of the circuit. The galvanometer is a current detecting instrument. We will be seeing that the galvanometer in the coming chapters. The switch or plug key is a device for making or breaking an electric circuit. A diagram which indicates how different components in a circuit has been connected by using the electrical symbols for the component is called a circuit diagram. The electrical circuit consisting of a cell, a bulb, and an open switch. It is shown in the nearby diagram. A bulb has been connected to two terminals of the cells by copper wires through an open switch. The circuit shown in the diagram is complete due to closed switch. Since there is no gap, therefore current flows in this circuit. And the bulb lights up. The circuit given in the diagram is broken due to gap because of open switch, so no current flows in the circuit and bulbs goes off. The electrons cannot flow in this circuit due to the gap produced by the open circuit. An ammeter A has been put in series with the resistor R This is to measure current in the circuit. A voltmeter has been connected across the end of the resistor R, that is, voltmeter is connected in parallel with the resistor. The voltmeter is to measure potential difference across the ends of the resistor.